Hi guys, good evening. So guys, today we are starting our Wireshark training.
Good evening.
This is going to be a 4 days training, and the duration for this training is approximately 10 hours. So on the screen, you can see the dates for this workshop, you can say for this course is 11, 12, 13, 14, 9 to 11 or 11:30 timing. And if in case somebody is not enrolled, they can enroll because for first initial 30 minutes, this session is streamed on YouTube just to check the quality and all. And after that, I'll stop YouTube streaming. And in the description, I'm putting a link. If anybody is interested, they can enroll on Zoom. Most of the people already, like everybody is enrolled. So not for the people who joined on Zoom. It's only for the people who is watching on YouTube. Okay. So Rohan sir, over to you. You can start.
Thank you. Thank you, Gaurav. Okay, welcome everyone and good evening. Let me start with my intro first. My name is Rohan and I carry experience of more than 12 plus years working in the cybersecurity industry, mostly working on to the firewalls and the SWG appliances. I troubleshoot. I have done a lot of troubleshooting from my day one till this point. I still am doing a troubleshooting, but it's refers to some different parameters and all. Now, while I have worked across multiple issues, there is something which I have grasped with reference to the Wireshark, which is
Sorry sir, actually by mistake you are on mute. So can you unmute yourself right now?
okay. Am I audible now?
Yes sir.
Yes.
Okay. So was I mute from the start or what?
No, just for a hardly 5 seconds.
Okay, fine. Okay, so like I was saying that Wireshark is a tool which is shadow for any of the network engineer, uh, because without the Wireshark, it's hard to imagine how we will be navigating through any of the problem that we may come across, right? So although analyzing any issue with reference to slowness, any issues with reference to intermittent drop, intermittent outage, so that would require multi-tool awareness in order to navigate your way around. Like you should, like, let's for example, if we take an issue where the customer is having some problem with reference to common accessibility of any destination based upon the web page and all. So in like that case, you may need to rely onto the HAR tools, log analysis, as well as parallelly you have to take a Wireshark capture, right? So the point is, if you are troubleshooting, let's say the problem with reference to VPN flaps, you are troubleshooting the problem with reference to one-way audios like SIPs and all, right? You are troubleshooting the problem with reference to the slow download and uploads with reference to the SMB transfer of the files, and likewise. So for all these issues, what I have mentioned, you might be needing some other logs as well. But one thing is common in all these, that is you have to take a packet capture. And when the packet capture is there, that means you have to be working onto the Wireshark, right? So Wireshark is a very key important tool for us in order to navigate around almost all the problems. And like that is what we are going to focus in this workshop, which is going to be for the next 10 hours, distributed in 4 days. So the focus would be to make you understand what is Wireshark, the common terms around it, the display filters, the settings of the Wireshark profiles and all, how you will take captures. So those basics stuffs. And then we will try to build up the foundation of Wireshark troubleshooting based upon some samples captured with reference to slowness, with reference to threat analysis, with reference to extract the objects, with reference to how we will be able to decode our SSL traffic, right? And also the VPN traffics, right? So all these will be covered into this workshop. So this is the broader uh, aspect of this workshop. Now, that being said, I just need to know about my audience here. Uh, how many of you have never worked on Wireshark or have no idea about network protocols? Or is there anyone here who has no idea about what is TCP, IP, and all?
So
Any
Wireshark, new for that. But remaining the protocols and all,
Wireshark might be new, but what about the knowledge about the protocols?
the protocols I have knowledge.
Okay, so you know this. So if I use the term like uh, sequence numbers, ACK numbers, size, TCP length, these make sense?
Yeah, makes sense. For me,
Okay.
makes sense, but others you can.
Yeah, so this is an open question for everyone who has joined through the Zoom.
Yes, yes. I understand protocols, everything, because I'm already working in the IT sector for last
Okay.
4 years. So I just wanted
Fine.
to like a deep dive into Wireshark.
Got it. Okay, so I am with the purview that everyone here is comfortable with the OSI model and the concept of TCP IP. And that being said, the main focus would be to deep dive into the packet analysis rather than focusing onto the protocol level, right? That is what my assumption is. Is that
Yes.
correct? Okay.
Yep.
Yes, yes, right. Yeah.
Because sir, most of the people already completed CCNA, CCNP or firewall. So like they are already existing student of networkings. So I don't think so
Okay.
anybody who is fresher or the beginner.
Okay, then it's great. Great then. Okay, so let's start then. So I've given you the overview gist that what we are going to be covering, the main emphasize pointers of this workshop. With that being said, let me share my screen now.
This will be
Okay,
recording. And
so
this recording
yes,
video will be shared as.
recorded video.
Yes,
Will
right.
go.
Yes.
Ravi, you are a part of group or not?
I'm in part of the WhatsApp group.
Yeah. So on that link, I'll share you one link where you need to sign up, and all the sessions are you are able to see the videos for a year.
Okay,
And
thank
see
you.
access for 1 year.
Okay. Fine. So starting with the Wireshark now. So you can download this Wireshark application uh, from the Google search. Just search for the Wireshark download. You will find a link there. Just download the file based upon whatever is your operating system, whether it is Windows, Mac, or Linux. Okay, so whatever you are working on, based upon that, just get the Wireshark downloaded from the official website, and then you can try to install it. While installing the Wireshark, just you have to keep in mind is please ensure to check mark npcap. Okay, npcap is must to have. You can skip usb pcap. Okay, that is something which you may not need for this workshop, because usb pcap is a software, or you can say as an add-on which comes with the Wireshark, which helps you to identify with reference to the usb devices. So that is something which you do not need, but npcap is something which you need. NPCAP will help us to capture the loopback related communication. That means communication between two applications within the same machine system. So if my Chrome is talking to the Teams or my Zoom is talking to the browser, so that is internal communication, because Zoom and browse and my Chrome is within the same Windows machine, right? So that communication will happen over the loopback, and that needs to be captured with reference to NPCAP. Okay, so npcap is something which you must check mark, and then it's just next install, right? So there is no brainer into installing the Wireshark for that matter. Okay, let me first arrange my Zoom. Okay. Now, that being said, so when you open the Wireshark, this is what you will see. Now, if you watch closely, here you have all the options, what you can play with, right? To set the filters and whatnot. Now you have this display filter, and this is your capture filter. The difference between that is that, see, currently when I open the Wireshark is not taking any captures, right? So Wireshark is telling you, okay, hey, if you want me to take the capture, tell me where, right? So these are the interfaces. You can see my cursor, right? So these are the interfaces that the Wireshark has identified onto my machine. Now it is showing you that on which interface there is a traffic. You can see these graphs, right? So the graphs are showing you that where the traffics are coming. So it's one is loopback interface. Like I said, this traffic, what you are seeing is for the intercommunications of the applications that is happening within your machine, not outside. Something which will be sent through your hardware, that is your LAN ports, Wi-Fi port, right? So the hardwares, the packet which will be moved to the hardware, that is something which will be captured either on the Wi-Fi or on your LAN ports, right? So it is showing you that where your traffic lies into. Now, wherever you want to take a capture, you will just select it, and then you can simply click on this blue shark icon and it will start taking a capture. But when you do that, it's a blind capture. Blind capture means you have not set any filter, right? And that is okay, because after all, this Wireshark will collect all sorts of traffic, right? So whatever is being generated on within your machine, it will capture everything, and later on you can just filter it. So that is called display filter. But if you want to capture, or you want to tell the Wireshark, hey, you just capture a certain specific traffic, then you will set a capture filter that, okay, hey, I only want to take a capture for this traffic. Okay, like HTTP only, DNS only, or something like that. Okay, but ideally you will not be setting onto that. It's like something you will take a blind capture, let it run. Once you have selected, like I have selected Wi-Fi interface, and then I started the capture. Now it is taking capture. So whatever I'm talking to, my Zoom application is running, my like browser is running, right? So whatever my internal processes would be running with reference to the Microsoft services as well, everything is getting captured. Now, if you think that you have replicated your traffic or your issue, then you can simply click on the red icon and it will stop it for you, right? So now your traffic has been captured, and now you can see that the capture has just stopped, right? Now, before I show you the filters onto this, how to check what you want and what you have captured, see one more thing here. Do you see this bottom, my cursor? It is showing you what? How many packets you have captured. 9,656 packets has been captured. Okay, it has dropped nothing. It's like why the Wireshark was taking capture, it has dropped nothing. Okay, so it is simply showing you how many packets you have captured. Now, there is one option of profile as well, which I will explain you later. Profile is something which you can define, like this is my default profile where I have added my customized columns. Okay, so now how you will be adding all those columns and all, I will show you. But for now, just know that you can click here and you can have multiple profiles. Okay, so if you want to add as many profiles as you want based upon your troubleshooting scenarios, you can go with like a configuration profile, click on the edit configuration profile, and then here you can click on plus, then write the name, right? So whatever profile you want to. So for example, if I am troubleshooting for, let's say, TCP traffic. Okay, so that's my TCP profile. If I am about to do that, so I will create one TCP profile, press OK. So now if you see here, now it is showing me as per the TCP profile. So these are the default columns. Default column means it is showing you the sequence number. The first column is showing you as the sequence number. This one is the time. Okay, I will talk some more about the time because time is going to play a vital role for us, especially when you are trying to share the capture with someone else. Okay, so that someone could be sitting anywhere in the world, right? So you and your partner to whom you are sharing the file, you must be working on the same time zone, right? So how you will convert this? So that is something also I will tell you. But for now, just go through the default columns here. That is, source is telling you the source IP. Destination is telling you about the destination IP. This is telling you about the protocol, what you have captured, UDP, TCP, SMB, STTP, whatever. Okay, so whatever the protocol that has been captured, you can see it here. Then this is about the length. Now, which length is this? There are two lengths. I will show you of one of the packet, okay? Let me be very specific here. Just give me a moment. I'll show you one thing. I'm just taking a random, okay? We will be having, we will talk thoroughly about TCP slowness analysis tomorrow. Okay, so that is something which we will deep dive into. For now, I'm just giving you an overview here. You see here, I have selected any TCP packet, and there is one length here. Do you see this? And there is one length. You might see, come on. Oh, sorry, I have opened TLS. This one, right? 50. Can anyone tell me the difference between these two lengths? The TCP segment length, what you see inside the TCP header, and the total length, what you see inside the IP header. What is the difference?
One is IP segment length, one is the layer 4, IP packet length, and one is the TCP segment length at layer 4.
So what do I mean by that? It's like if we are seeing this value, what does it tell you? What do you understand by this?
It's the encapsulation length, or
Okay, let me tell you. Simple, okay? So let's talk about some small thing, and then I will come back to the Wireshark filters. I believe everyone knows about, okay, in which part does the MTU lies into? If I talk with reference to the OSI model reference. So MTU is something which you set where? Layer 3, layer 4, layer 2, where?
Layer 2.
Layer 2, okay. What is MTU? If I say what is MTU, then?
Maximum transmission unit.
Maximum transmission unit. It means what? What does this mean?
Which
How much
packet?
traffic can you flow? One packet can be the size of 1500. If it's more than that, it will break it down into smaller packets.
I will come to the fragmentation concept later on. But first, okay, okay. So everyone knows that by default, the MTU value is 1500 bytes, right? Everyone knows that, right?
Yes.
How has this value come into play? Why it is not 1600 or 1700 or something?
That's the standard across all network devices, I guess.
Okay.
It's a frame size.
Okay.
Layer 2 frame size, I think.
No.
40s.
MSS. What do you understand by the term MSS? Maximum segment size. Actual data inside a packet. Have you wondered when we say, okay, hey, I have sent a packet, let's say, okay, so now I'm taking a deviation, a small deviation from the Wireshark. The reason behind that is because I'm getting a gist that some basic fundamentals are not clear. You might be aware of it, but my job is to brush it up. because these things are vital when we are going to touch the TCPs and all, right? So that for that reason, I'm just deviating from my Wireshark for the moment. Okay. Now, see, when someone says na that okay, I have sent a packet. Okay. Now that packet contains a certain set of headers, depending upon whether that packet was generated from the layer 7 or it's a layer 3 based protocol or it's a layer 2 based protocol, right? So based upon that, a certain headers will be mentioned inside it. But that packet is supposed to carry the data. Now, what is that data that a packet is carrying? Right? So we are talking about that what maximum size of data I can send inside a single packet. So when you will go in that aspect, then the default, or you can send maximum 1460 bytes, not more than that. In a single packet, you can only have maximum 1460 sorry, 1460 bytes. Okay. I am not saying that each packet will contain this much, but this is the maximum what a packet can have. What? Data, actual data, the payload. Clear? Now, your MTU is actually derived from what? MSS, that is the total data size, plus IP header plus your TCP header or UDP header, whatever you take it. So MSS is how much? 1460. IP header size is 20 bytes. TCP header size is 20 bytes. If you will sum it up, it will come as 1500 bytes. Got it? Got it?
Yes.
How did you get the
Yes.
MTU size? So MTU is, so when we say now that maximum transmission rate, meaning what? That what is the maximum size of a packet that I can send at a single shot? Okay, so when I will send the packet out, so what is the maximum size of a packet that I can send out from my interface? So that is 1500 bytes. If your packet size is greater than 1500 bytes, then the devices will fragment it, right? So keep in mind, this is the reason why fragmentation always happens at egress. It never happens at the incoming interface. Never. It's maximum transmission unit. It's not maximum receiving unit. Receiving is decided by your buffer size. So let's say I have a firewall or a router which has a 1 gig of interface, right? You might have heard of that this device has a 1 gig of interface, right? So 1 gig of interface means what? That this interface capacity is 1 gig, right? He can handle that much traffic. Okay. So that is what is deciding his buffer size. So MTU has no role to play when a device is receiving the traffic. MTU has only the role to play when the device is sending the traffic out. Clear? That's why fragmentation happens while the packet is being sent out, not while receiving it. Make sense what I'm saying?
Yes.
Okay.
Yeah.
Yes,
Now,
sir.
coming back. Now see here, focus. Just take any random packet, okay? Just take any random packet, whatever you want to. Just pick it up. Anything. Okay. Now see here one thing. Now 40. Okay, let's take this one. Now do you see this IP under the IP header? The total length is 107, right? Now see the segment length 67. If you will just try to subtract that 107 to 67, what you will get? 40? Yes or no?
Yes, correct.
See now, total length 107, and under the TCP segment length is 67. The difference is what? 40.
40.
Meaning what? This TCP segment length is your telling what? Data.
Data.
What is the data that this TCP is carrying? But when you add the IP header 20 byte and when you add the TCP header 20 byte, you get the total length of the packet. That is 107 byte. Make sense? Make sense?
Yes.
Yep.
Now the question is, we are clear with these 2 pointers, right? Now why I am seeing here the length has 121 then? Anyone? Why the length is 121? What is the difference between 107 and 121?
The Ethernet header.
No, I'm talking about the size. What is the difference between the size? 107 and 121,
14.
what is the difference? 14?
14. Yeah. 14. Yeah.
Which header has 14 bytes?
Ethernet.
Yes. So when you add the Ethernet also, then you get your frame length. Someone was telling me that it's a layer 2 or something. Some people were telling me, right? It's
Yep.
not, that's your frame length, 121 bytes. That is adding the Ethernet header. Now you get the concept of length. Okay. Yes or
Yep.
no?
Yes.
Okay. Now keep in mind, this is very vital for me to understand the total length and this TCP segment length. This is very vital for me to understand because we will be using this in order to analyze the slowness into our traffic whenever you are dealing with a TCP based protocol. Most of the protocols that we work on is likely to be using TCP at the layer 4. Okay, so this is going to play a vital role onto that. When I will show you the TCP graph plot in order to track how to determine the slowness and problems within your TCP communications, there this will play the role onto that. Okay. Now that being said, okay. Now see here. So let's take a step back and be clear with the Wireshark terms first. Now, like I said, see this is the display filter.
Rohan, just
Yes,
one
please.
question.
Yeah.
Now you said me that 67 and 107, this may be the slowness of the system. So how we
No,
can,
this is not the slowness of the system.
okay,
I'm not saying this is the slowness of the system. I'm saying that these values, means like parameters, will
okay,
help us to determine the slowness if there is any within the system. In like
yeah,
conjunction with the window size. So there is also a factor which is going to play a role in here, that is TCP window size. Okay. So there we will come into play. So now we will talk about receiving window size, sender window size, and like we will see the graph between them. Okay, so all these things will come into play.
so all
Fine.
this, based on this, we can conclude the system is running the slowness issue.
Yes, and it's not about the system. It's see, being a troubleshooter now,
Hmm.
the thing is, when you look at the Wireshark, do not try to fix a problem. And this is what I say in my firewall batches also, that whenever you look at the problem, do not try to fix it. Because when you try to do that, your approach changes. Now you are bound to do a biggest blunder which you should never have done. That is presuming things. So like, let me give you an example what I mean by that. Let's say if I say, or let's say a customer called you and told you that, hey, I'm having an intermittent problem while accessing a destination called yahoo.com, let's say. So if you try to fix that problem, then what you will do is, okay, fine. Is that DNS working? DNS for that yahoo.com working or not? Can you check if the internet is reachable? Let us check the logs on to the firewall, whether the session is getting dropped or not. Let us verify the configuration to which policy you are mapping to, right? So see, what you are seeing in this way is I am trying to troubleshoot. But what I'm doing is I'm doing a blunder here. I do not have any action plan. I am hopping from one point to the other, right? I am taking a second guess. Okay, could be the problem with the configuration of the policy, could be something else, could be DNS, could be internet, something, right? So I'm taking a guess. There is no path. But when you change your mindset, that means never try to solve a problem. That's not your job, to be honest. If you think that your job is to solve the problem, you are mistaken. Your job is to narrow down the problem. A user could not have been able to access a website because of 100 reasons, right?
Yes.
Maybe lag in the DNS, maybe failure into the DNS, maybe wrong DNS routing, maybe some problem with his DNS cache entry, maybe he is having the problem with his gateway reachability, maybe some wrong routing could be causing that, maybe some like a kind of loop within the network could be causing that packet drop, and hence it is not reaching to someone, it's like some other next hop devices. Maybe because of the corrupt MAC table onto the switch could have caused this problem. Maybe the configuration onto your firewall would have caused that problem. Maybe some proxy what you have deployed could be stopping that. Maybe some sort of an UTM features what you have configured onto the firewall could have been blocking somewhat or the other. Maybe the subdomain which is been accessed by that parent domain is actually getting blocked. As a result, the main domain is affected, right? It can be anything and some more, right? The point is, if I try to solve it, then I'm taking my second guess. And maybe I will solve the issue in 5 minutes, maybe in 5 days, or maybe never. Who knows? But if I follow a plan, my job is to narrow down, right? When I say narrow down, that means I'll start from A, B, C, D, like that. Okay, let me check at the point 1, then 2, then 3, then 4. So I am ruling out, okay, okay, DNS is not the problem, gateway is not the problem, cache is not the problem, this is not the problem, right? So that's how I'm moving ahead. So when I do in that way, dead sure I will be ending up finding the root cause and hence followed by the solution. Okay, so that's what you have to do. Now, when I say this, okay, this is why I'm saying that when you look onto the Wireshark also, try to look in that point of view. Okay, do not try to find the problem here. Try to narrow down. And that's where your knowledge about the protocols will come into play. So when I open this, let's say for example, I'm just giving you an example to support my statement here. So if I open this TCP, I see some informations here, right? I must be very comfortable in reading all these informations, what is there. So what is sequence number? What is raw sequence number? What is ACK number? What is raw ACK number? And how the sequence number is changing, how the ACK number is changing. Okay, so I should be able to understand all these pointers. Then only I will be able to make a call where is the problem, right? Got it? What I'm saying?
Yes.
Okay, so see, protocol is something which cannot be taught in a day or two, to be honest. That is something which you will eventually get used to it. The more you work onto it, the better you will get into it. Okay, but yes, I can give you a way path around a mindset, how to find your way across the packets. Okay, now that being said, which pointer I was at? Okay, so see here. So you can see this display filter, right? So now I have 9,656 packets currently. If I press enter, you will see that I have 9,656 packets. Now, if you want to look something into it, right? So you can set the filters like, for example, you just write TCP dot, and yes, one more thing. I do not suggest anyone to cramp the filters. Do not do that. Okay, do not. Wireshark is there to help you out. Like I wrote TCP, it showed me all the options. See, you can see that. So you just write TCP dot flag. Let's say I am looking for some flags. So TCP flags. Now you can see all the flags are listed here. whatever you want to set the filter. Okay, hey, show me the packet. Let's say I want to see the first packet of any TCP session. Now we all know that when the three-way handshake of TCP happens, what happens? SYN will be sent, first packet. Why we say that the first packet is SYN? Can anyone tell me why we say that the first packet is SYN? Guys, why do we say that the first packet of a TCP three-way handshake is SYN?
Initiating negotiation with the neighbors.
So why that first packet is called or referred as SYN? Because in that packet, only SYN flag is turned on. Rest all flags are marked 0. Keep in mind, one value means on and 0 means off, disabled, or you can say true or false. Okay, so this is true, and this is false. Okay, however you want to put it. If I will show you the SYN packet, now see, let's say if I have to find out that how many TCP sessions I have captured.